All right. Welcome, everyone. Thank you for coming to see my talk. I'm Sebastian. I'm a director of engineering at Openshift, and I'm here to talk about the operators and the operator framework. And this is to go a bit deeper into the material than yesterday. First of all, I would like to ask, who here has been to the talk yesterday that was an intro to the operator? All right. Quite a few, so that way I know how to modulate what I'm going to say and what I'm going to present. Great. So yesterday we talked about operators, what's an operator, what the operator framework is, and what different components they are. I'm going to go over this briefly again today, and I'm going to do a couple of the demos that I did yesterday again, just so that everybody sees the same things. But the thing that I'm going to add that we didn't do yesterday, and to go a bit deeper, I'm going to be building an operator, a very simple operator, something that you'll be able to replicate yourself by just going to the docs and try yourself. But the goal here is to show you what it takes, what pieces an operator is made of. All right, let's get started. So what's an operator? A few less slides than yesterday. An operator is a way of building an application and driving an application on top of Kubernetes behind Kubernetes APIs. And the idea is that when you have an application like, say, a database like Postgres or Cassandra or something like Redis, doesn't matter. Any complex application will need a lot of domain-specific knowledge. That domain-specific knowledge can be, you can use Kubernetes and help yourself to those generic tools that exist in Kubernetes, like stateful sets, CSI, deployments, ingress, to help you try to solve some of those domain-specific problems. But in the end, when it comes to really fully automating an application, and by fully automating, I mean handling updates from one version to another without waking people up, handling failure recovery if it's needed, scaling the application up and down depending on some scenarios, all of that should be handled automatically. Humans should not be involved in this kind of operation because that kind of breaks the promise that containers gave us. Containers' promise was, hey, you package it once, it runs everywhere. Well, that's true for developers, but in production, there's so much more that needs to be done. And so operators is a pattern. You take all this domain-specific knowledge, you put it behind Kubernetes APIs, you extend the Kubernetes APIs thanks to CRDs, and you're able to then build it once, and then be used by users again and again, like a cloud service, just like you use RDS. On AWS. You go and you ask for a new database. You need another one, you ask for another one. The same thing should be true for any kind of open source or closed source software that's running on top of Kubernetes. You should be able to just ask for an instance of it and use it. You should not have to understand how to deploy it and manage it. So that's the promise that we're trying to fulfill. That's where we're trying to go with this. This is very early stages of all of this, but there's been a tremendous amount of people that jumped on this and wanted to also operate automatically. And so across the industry, we've seen more and more things. We've come out with our own. We have things like etcd and Prometheus that allow you to automate etcd and Prometheus completely automatically on top of a Kubernetes framework. And these two come from the communities themselves. The etcd operator, the Prometheus operator is maintained by the Prometheus community. And then you can have either vendors or communities or authors that are building these operators. So you have things out there like Postgres or Couchbase or Redis. And we've made a list. There's this URL. If you have an operator and you want to contribute to it, you can go add it to this list. This is very open. We don't require you to use any special technology. Anybody who has something that applies to this logic is allowed to come contribute it there. Eventually, we're going to find a way to expose those operators better to Kubernetes clusters. I'm going to show a few of these during my demos. But that's the bulk of it. That's the idea. The idea being not to have to do things over and over again. All right, so let's start with the operator framework. What's the operator framework? Well, building an operator is not easy either. You need to know a lot about Kubernetes. Kubernetes is a wonderful API. There's a lot that you can do with it, but there's a lot of details that you need to know. You need to become an expert. Automating your application is something where suddenly you have to be not only an expert in terms of your application, but also in terms of Kubernetes. That is quite a lot at once. What we're trying to do here is trying to give a set of tools, a set of projects that we've bundled together but are all usable independently from each another to help build operators. That's, for example, the operator SDK. So how do you build an operator? How do you package it? How do you test it? If you're going to ensure that this is a repeatable process, if you're going to make sure that this is going to be, people are going to install it and trust it automatically, just like people trust apps being updated on their phones, then you need to make sure that tests goes along with it and that people can trust that it's going to work in their environment. The operator SDK also gives you a lot of generic tooling. A lot of things can be abstracted. A lot of things can be done for a certain set of class of software, like databases, or some things are usable by all software, like, for example, setting up monitoring and making sure that your app, once deployed, is automatically monitored by the local Prometheus instance. Or things like rotating TLS certs, upgrades, all of this, there's a lot of generic code that can be done and helped there. And also an abstraction to Kubernetes, helping people to not have to deal with all the details, but only the higher level to get started, to be able to focus on their own domain-specific code and their app that they want to build. Once you have such an operator and you have built it, you need a way to run the operators. An operator can run, it's just another Kubernetes application, so there's nothing special about it. But once you start having a lot of operators, they have their own versions, they have their own life. And we've built something called the Operator Lifecycle Manager, an operator for operators. It helps you subscribe to different channels of operators, know, for example, that that operator will always be stable, that one will always be preview. It allows you to decide what namespace is allowed to have operators and what not. And it also allows you to make sure that upgrades are either handled, of operators are handled automatically, or if you need somebody to approve an upgrade, all of these things are done by the Lifecycle Manager. And then another component of the framework is what we call metering. There's a whole talk about this on Thursday, and I encourage you to go. This is about measuring what's happening in your Kubernetes cluster, collecting it through Prometheus, and then, most importantly, being able to create reports on top of it and do things like chargeback or showback, knowing, thanks to logic inside of an operator, for example, how much a certain table costs on AWS, or how much you're spending for a certain amount of traffic on the other side. That is what metering can do. It can aggregate these metrics and then create reports. All right. So next thing is demo. That's the main thing that I wanted to show here. And we're going to go over a lot of the concept that I've talked about in a high level in a more detailed way during this demo. All right. So let's start with an Openshift cluster, which is a normal Kubernetes cluster here. I'm not going to be showing things in the UI yet. We're going to first start by building an operator. But later on, we're going to come back and have a few looks at what we can do with the Operator Lifecycle Manager. So what does it take to build an operator? Maybe I'm going to make the font bigger. Let me do this here. There's a lot of commands, so I'm going to copy paste. There we go. And then, OK. So the idea here is that all I have installed as a command is the Operator SDK. That's a command that I'm going to be using. Currently, I don't have a project yet, and we're going to be building a Memcache operator. A Memcache operator is an operator that you can run, and then if you need a Memcache cluster, you can just ask, I need a Memcache cluster, and give it the size of the Memcache cluster that you need. If one of the Memcache instances in that cluster dies, the operator spins it back up. So let's start by first creating a directory, which you've had, and now we're going to do something which is called, it's the first command you do when you use the Operator SDK. It's called Operator SDK new. It's when you're from zero, when you don't, it's like git init. And this is going to bootstrap the Operator SDK directory and the boilerplate code that you're going to need to start building an operator. Currently, it's installing all the dependencies. The dependencies that you're seeing being installed right here is quite long. These are all the dependencies that you need when you want to start using things and talking to the Kubernetes API. There's a bit more in there, of course, that the Operator SDK needs, but it's still quite an amount of things. Most of it gets pulled automatically when you take client Go and API machinery, but still, it's quite a lot to know and quite a lot to process. This is going to be done in just a bit, and we're going to be able to go from there. All right, so now I have a directory with a Memcache operator. This doesn't do anything, obviously. This is an empty shell. I could build it. If I were to deploy and build this now, it would be an empty API that does nothing. So we're going to start doing things. The first thing that you want to do is, if we're going to build a Memcache operator, we need an API. We need a CRD, and we need to be able to tell it what fields and what options it takes. So the SDK generates all that boilerplate code and scaffolds the rest of the project. So in this case, I just ran a command called add API. I'm creating an API that has the version cache.example.com v1 alpha and is of kind Memcache D. And what's interesting for us here is to look at what it looks afterwards. Let me just copy it over. That's the one here. So if we look at this, this is going to be our API. So we're in Go code here because we want to express in Go code how it's going to look to the operator. This is a generated file. The thing, I've copied it in because I've altered one thing, which is this file and this line here, size, and this line here, node. The way CRDs work is you have a place where you can submit fields, and then you have a status that gets written back by the operator. And we're currently building an operator that takes the size of the cluster, how many Memcache instances do I want, here, and then reports back how many nodes are actually running, here in the status. These are the two fields. You see where this can go with more complicated projects. More complicated projects will have more inputs and more outputs, and we'll be able to show that. The rest is usually generated, but can be edited if needed. The next thing that we need to do is, well, now that we have an API, we need to act on that API. So we need to build a Kubernetes controller. Again, we're going to generate most of that code by calling operator SDK add controller, again an API, a kind, and now I'm going to copy over the code of the controller. You can find all of this on the website itself. In the repository. And there we have our controller. So this is the code the actual user wrote. This is the business logic. That is not generated. Like, this whole reconcile function is the heart of the operator. What happens in the reconcile function is it looks at the state, it gets called periodically. And periodically it then looks at the state of the world. Do I have Memcache running? Well, do we? No. All right, let's start Memcache. Let's start a deployment. Is it big enough? Is the size big enough? Yes? Good. No? Update it. And then builds a status update and updates the CR, which is here. Like, you can see it here, for example, when it does the update. And the idea here is that we constantly get in this loop. And this is how an operator works. Looking at the state of the world, what do I want? Fixing that state. This is how upgrades would be handled. This example doesn't handle an upgrade. To be fair, in Memcache, it might not be that hard. But for a more complex application, you would be looking, what version do I have running? Do I have to run certain migrations? What do I do to go from point A to point B? That's what you care about in that function. And that function is your human. The human that's usually behind a pager and wakes up and brings your servers back up and fixes it and does all that. That's what that loop does. We can go way further than that, and we're going to show some examples that are not just a loop to keep something up, but also something to APIs to interact with an operator. But that's the main goal here. All right, so now that we've created this, we've just copied code in, right? We just coded, we just edited the files. So we're going to generate, we need to call the operator SDK to generate the actual code, and then we're done. We are going to be able to build it. So the first thing we're going to do is build a Docker image that contains all of this. Then I do have files here that are generated by the SDK about how to deploy it, the permissions on the Kubernetes cluster, the service counts, The operator.yaml is the deployment itself of the operator. So now I'm going to just quickly swap the image name for the one that we used. You can see Quay.io, SPAL, Memcache D. That's the one that we used when we built. So now our operator will be deployable. And now we're going to quickly push this operator to Quay. I've tried this on conference Wi-Fi. It's OK. So, and we weren't able to install the deps. All right. Slower than last time. But look, the layer already exists. It took all that time to tell us. I could cheat and Control-C since I've already updated this. Oh, no, we're done. All right, I'm impatient. OK, so let's now see what we're going to do. First, what do you need to run an operator? First, you have the CRD. This was generated by the custom resource definition was generated by the operator's decay. It declares what kind of custom resources we can do. In this case, we want to start putting new Memcache instances with certain sizes. So this is to declare the CRD. Then, so let's create that one first. Done. Then we have the service account. So the service account, also a file generated by the SDK. That's obviously the operator needs to run as some user. That's the user it runs at. And then the role and the role bindings are the permissions that certain user has. And now we're going to start deploying the operator. Well, that we're going to have a look at because this is a normal Kubernetes app. This normal Kubernetes app here deploys the Memcache operator. So it's a deployment. It uses the service count that we just created. It binds on a certain port. It uses the image that we created earlier. And we have a couple of readiness probes and then some environments. But that's it, like which namespaces we want to be watched, the operator name. But as you see, normal Kubernetes application. So we're going to deploy that one. Done. And now we can do a kube control get deployment. Great. This is definitely slower here than in the lobby.
Everybody off the Wi-Fi.
Let's go to the UI. Who cares? Oh, of course. There we go. We have the Memcache D operator. It's running. So the next thing that we want to do is we want to start deploying instances of this. You can see that I have two other operators running as well. How do we instantiate a new Memcache? Very easily. I give it a name. In this case, let's call it KubeCon Memcache D. And a size. We want 3 Memcache nodes. And there we go. And so we just kubectl apply. Go. And then we can do a get again of our deployment. And then we can see that we have KubeCon Memcache D running at the size that we asked for. We can also look at the pods. Oops. We can look at the pods. We can see that we have 3 pods running. We can have a look in the UI as well, because why not? And then here, you can see all these Memcache D operator pods. Let's kill one just for fun. If I delete this pod, then we can see that it is gone. Oh, it's been replaced too fast. Oh, is it? It must have been replaced. Oh, it's still terminating. Oh, I killed the operator. Nice. It's been restarted. Kubernetes does a few things for you, so we're all good. it's not bad to kill an operator. It'll just come back and continue its job. But let's now actually kill a Memcache D. There we go. So it's terminating, but it's already back while it's terminating. So there we go. So we're back. So I killed a bunch of things and nothing happened. This is what we want, right? Like that's the goal. All right. Okay. What can I do with this? Let's see. I have a new API in my Kubernetes cluster. Let's look at all the CRDs. You will see once this loads, there are a lot of CRDs in there because this is Openshift 4.0, and Openshift 4.0 is fully built on operators. So you have CRDs for pretty much everything in there. If this loads on conference Wi-Fi. Go. This takes forever. While this loads, let's do something else. Let's edit our thing here. Let's increase the size. Obviously, we can also have like 10 in there if we want. Come on. The CLI is faster right now. All right. 10 Memcache Ds, right? Like, oh, why doesn't it load? I have too big of a list here. All right. Well, I'll leave this on the background. Let's go a tiny bit to this. All right, so in this example, we saw a Memcache D thing. Oh, one last thing that I like to show as well is this. Obviously, this is meant to do multiple of these. So I can do a Memcache D2, store this, apply. And now, if I get the pods, I have 2 instances running. These are 2 different Memcache D for 2 different applications. And they have 2 different names. So all it takes is this. Instead of having a lot of YAML to deploy Memcache D all the time and also knowing how to maintain it, you just have to include this tiny YAML here with the rest of your application. Okay. Oh, it loaded. Beautiful. Okay, so in here we can see that we have Memcache D here. And so you can see them. You can see that I have the 2 instances running there. This is the that's the interesting thing. You can see that they all are present as their own API in the cluster itself. All right, let's go on with continuing. What are other options to build operators? You saw a lot of YAML here, a lot of Go code. There are other options. The operator SDK supports what we call Ansible operators. So if you have already a lot of Ansible code, let me go in there, operator framework, operator. That again, I'm showing you things you can see in repositories on the internet, but here you can see that you have things like the Memcache D operator. And the Memcache D operator, 1 second, this is not the right thing. Ansible, there we go. So here we have an implementation of the same operator that I did, but in Ansible. So it uses the operator SDK, but what it does behind the scenes is it drives Ansible code. So all you have to do is basically create an Ansible role, point to it, and then you can do things like saying, having inputs, like you have a size, and you have a task that needs to be accomplished. And for example, when you start Memcache D, and that thing has the definition to run, the Kubernetes definition to run Memcache D. So that shows you how to do the same thing that I just did with only a bit of Ansible. And we can do this with Helm and Ansible. And the idea is that in the future, you'll be able to mix and match Go code and Ansible, or Go code and Helm code if you need to create more complex operators. So that's that. The last thing that I wanted to show here is inside of the OLM, the Operator Lifecycle Manager. I showed a few of these a few pieces of these demos yesterday, but I wanted to just show this when everything gets put together. So when everything comes together, the operators are exposed to the operator's lifecycle manager with files that we call cluster service versions. It's a big YAML that describes what an operator depends on, what an operator requires, and you can start building dependency graphs between operators, and you can start also reporting status in ways that this operator's lifecycle manager understands. So if you look at the instances currently, we don't have any instance running. So let's create an etcd cluster. Same way that I created the other one. We're going to call it example, size 3, create. And then when we create this cluster, we can see that it starts up. And when we go to that cluster, we're waiting now. So what we're waiting on is on the operator to return status and to tell us that everything went OK and that the cluster is up. So you can go have a look at the resources to see if they're already there. So right now we only have 1 running, 2 running, 3 running. So now we have 3 etcd instances running. And if we go to the overview, you can see that the size is of 3 pods, but there are only 2 members that are active yet. Why? Because this is actual status reported by the operator. The operator has custom logic that knows what an etcd cluster is and reports it back, and then we show that. We show that, and now you see 3 members. We show that so that you can actually know and depend on the fact that the etcd cluster is up and not just pods running. So these are examples of custom logic that can then abstract it and be shown in one way. The etcd operator has more than just being able to do new etcd clusters. It can also create etcd backup and restore tasks. You have other operators that are doing things like the Prometheus one, that you can insert Prometheus rules or service monitors. Service monitors, for example, are a YAML object that tell a running Prometheus cluster to start watching another operator or another task or anything. And the cool thing here is that eventually we're going to get the operator SDK to generate those automatically. And so once you start playing the dependency game, you're going to be able to, through OLM, install a big fleet of software that all depend on each other and start watching and monitoring each other just like intended. So that's kind of the Legos that we're putting together to try to make all of this work. That's what I wanted to show today. That's it, yeah. The next things that I wanted to say is that there are how to get started. So please go to the website, the Operator Framework website. And please also go to the Openshift Commons group, where once a month we have a discussion. And we also have a mailing list and a Slack channel. Yep. That's it. Thank you. And there are more sessions. Please go to the other sessions. Questions?
Thank you for
Sure.
introducing to that. It's on now? Okay. A couple questions I had. One of them was related to dependencies, and this is an issue I have with Helm. When you're installing an operator, you have to install it separately, and you can't say, oh, this Helm chart depends on this operator, right? And from what you were describing at the end, it sounds like you're working on a way to address that. What are your thoughts on that, and how do you think you can fix this problem of like, oh, there might be things that depend on different versions of operators and running them both at the same time? How do they talk to the right custom resources?
So 2 things. In the operator lifecycle manager, where you can require other operators, depend on other operators. But where we're really going is for operators to tell you what APIs they're using inside of a Kubernetes cluster. If they're depending on a certain amount of APIs and if we're declaring the APIs they're using, we can easily say if something's going to work or not in addition to tests, versus just depending on versions that you don't know if it's going to work. So that's the idea, is that thanks to knowing what APIs an operator uses and knowing what dependencies are declared when you put it in the CSV for Operator Lifecycle Manager. All right.
Thanks, Sebastian. Can you talk a bit more about how a service like etcd could automatically update itself and how an operator facilitates that?
So the way it works is you have the operator running, etcd operator running, and it's deployed new versions of, it's deployed a certain version, let's call it version A of etcd. And then you update the operator, and this operator is capable of handling version B of etcd. And so what it happens is that operator then has the logic, the migration logic, to go from version A to version B. And so it executes that logic and starts rolling it through the clusters that are running. And you can decide if it should be automatic or if you should approve each update. Like, that's up to the cluster administrator.
I was wondering about upgrading to GoMod vGo. I didn't see any issues in the tracker, so I was wondering if there was timeline or
updating to what?
GoMod.
Oh, we've looked at it. Honestly, if the community wants to do it, they can start. We're going to get to it. It's just has not been a priority. That's it. But we will probably. There might be dependencies that we have that have issues with it too. It's quite possible, right?
Okay, I have two questions actually. The first one
Sure.
is about best practices around creating an operator, because there are some things on the site, the GitHub page that talks briefly about that.
Yeah.
But I wanted to see if there's anything coming out that gives people best practice around creating that. The other question I have also is what is your recommendation about running the operator inside or outside the cluster? Because I know in that documentation it allows you to do both. So what do you recommend as far as that goes?
Best practices, we're trying to encode the best practices inside of the operator framework, but we're also trying to document them. So that's our goal here, and that's an ongoing effort. And then running inside or outside the cluster is for development. If you're on your machine and you really want to iterate quickly, that's why you run it outside of the cluster.
Thanks, Seb. The question I have is about managing the underlying Kubernetes like objects like pods and deployments. Is there, with the Memcache one, you used a pod. Is there a reason to use, manage at the pod level or the replica set level within an operator, or does it depend on the use case?
It all depends on the use case. Yeah.
Yeah, my question is about this dependency graph you talk about. Is there another operator to manage all these dependencies?
That's OLM.
And is it something already existing, or is it a work in progress?
No, it's everything. There's not a single thing that I showed here that's not open source on the websites that I showed in the link in the slides. And I've uploaded the slides and all of that, yeah.
Thank you.
You can use all of that today. On any Kubernetes cluster, doesn't matter.
I just had a quick question about leader election. Is there anything in the framework that supports that right now, or are you kind of just dependent on deployments for keeping one copy up at a time?
The SDK itself does leader election between its members. But there's so much more that could be built. Yeah.
Okay.
How are we going?
There's two questions in the front
Pass it
here.
down, you're not gonna run that fast.
It's on.
It's on.
So the question about testing, so you kind of touched upon it, but I know looking at all this complexity going up and up, so how are you going to test that?
Yeah, that's a piece that I didn't show. I favored showing the Ansible stuff instead. But the idea is when you're building an operator, you're also building the tests that go with it. And we're also trying to add as many generic tests as we can within the framework to make sure that you handle a lot of these things correctly. That's what we're hoping for. Making sure that building tests and test suite are a part of building an operator, and also not letting things run if everything is not green and checked. And so when you're going to get an operator, the tests will be embedded, at least with the operator framework, tests are embedded within the operators. So when you get it on the cluster, you can run its tests. So before an upgrade, you can run its tests. That depends on the tests being good.
Yeah, so a couple questions. Where was the YAML for the pod that was deployed? Is that hard-coded, or can that be...
I should have shown that. That's in the source code, yes.
Okay, but can that be...
It's not YAML. It was a Go object. So I showed it in Ansible. Like that same YAML I showed in Ansible exists as Go objects inside of the Go source code.
Is there a way to make it that configurable, like get it through the CRD somehow?
Anything you want, it's your Go code, so you can expose any piece.
Okay, and the second thing is I just used Operate SDK like a couple of weeks ago to create a custom operator, but I didn't want to do any of this fancy reconciling stuff. I just wanted it more as a watcher to just get information from the CRD and just send an API call out. Is there some sort of a support you're going to have just for like a custom controller, like a handler, like that doesn't come with this whole reconciler?
So it's not there's always a loop because you're watching a CR and you're reconciling something. Okay. But if that's your use case, it's doable. Like there's people who are building operators that call out to cloud APIs to do things, right? To instantiate AWS instances, to create whatever they want outside of their Kubernetes cluster. That's also one of the big pluses of the Ansible. You can, like, despite not wanting to write code, you can also just write a lot of Ansible that goes and does things on your physical network.
Okay, cool. Thanks.
And there's one up front.
Hi, is there still a role for overriding custom controllers at all? I mean, should this all be handled with operator framework going forward?
No, I mean, the operator SDK is focused on really making it easy to build applications, right? Like there's a lot of low-level things that you can want to do and specialized things that you would want to do with the other APIs. What we focus on is for people who are building applications to automate them. Like that's our level. That doesn't mean that it's not, you can't use the lower level things to do more detailed work, or sometimes you need more control, right? Like, but it's two different concepts. A controller, an operator is like a superset of a controller. Like controllers, less than that. That's it.
So my question is more from a design of an operator, basically. So if for around the application workflow again. So if the application has multiple executables itself, what's the best practice to design the operator? Is it like, should we run a pod for every executable? Should there be one container for each executable, or just
it depends on your application, right? I would say some might have one image with all the executables, but multiple pods. Some might have multiple images, multiple pods. Some might have one pod with multiple executables. It really depends on the application. That's normal Kubernetes concepts, and then you decide if these concepts should be automated or not. All right, I think we're over the time.
Yeah, I think we're over the time. Can you go back one slide and
slide.
I'm just going to remind everybody, the SIG meeting is the third Friday of every month at 9 a.m. Pacific. If you sign up for the Google group here down at the bottom, you'll get the announcements for it. And if you have an operator now and let us know about it, we'll make you talk about it and talk about your experiences and get feedback from you. So please do keep in touch.